Okay, so your IXLs on Friday were 3-5 IXLs. They were reviewing the odd. So like if it's positive, even, what does the graph look like? Up, up. If it's negative, even, the graph is down, down. And it doesn't tell me anything other than it starts down, ends down, right? If it's positive, odd,
Down, up.
it ends up, so it starts down. Yes, down, up. If it's negative, odd,
Up, down.
it ends down, so it has to start up. Okay, the other thing it reviewed were finding zeros. Zeros. What's another word for it? X intercepts. Or solutions. Okay, they're all the same thing. We do them all the same thing. We set it equal to 0 and we factor. In your IXL, they had factored things already, didn't they?
Yeah.
So you had to set each one of these equal to 0, and you had 3 mini equations, didn't you?
Yeah.
So my zeros are -2, 1, and 7.
Yep.
Okay, so that's what we're going to be starting with today. We're going to be working with those. But we have to get it. Like we'll be identifying the end behavior. And we will be finding zeros so we can graph in 3.6. Okay. Reviewed that. Okay, so multiplicity of zeros. Okay, so if I have x minus 7, there's an exponent right here that I don't write. What is it? 1, right? So that means x equals 7 one time. It has a multiplicity of 1. But what if I have x minus 7 to the third? Isn't that equal to x minus 7 times x minus 7 times x minus 7?
Yeah.
Yes? So it would be x equals 7 with a multiplicity of 3. We talked about multiplicity before?
No.
Okay. So 1 is an odd number, yes?
Mm-hmm.
And 3 is an odd number. So at the graph, it's like an open door. It's open. But what if I had x minus 7 to the second? That would be x equals 7 with a multiplicity of what?
2.
Of 2?
Yeah.
Okay. What if I had x minus 7 to the fourth?
7 more to 4.
Multiplicity of 4. So when it has an odd multiplicity, the graph crosses the x-axis at the 0. But if it has an even multiplicity, so odd, even, the graph bounces off the x-axis. At the 0. Okay, so I'm going to do my demonstration I do every year when I introduce this. So if I have a door, like in your bedroom door, when you open it, it just opens and stays open, right? So if I touch this door once, multiplicity of 1, what happens? The door's open, I can go through. Okay, so this is my x-axis. But if I touch it again, what happens? It closes, and when I go towards it, what's happening?
It's shut.
No, what am I doing? Bouncing off of it. So what's the graph gonna do? Bounce off. The graph is gonna go to that x-intercept and bounce off because I opened the door and reshut it. So I have a multiplicity of 3. Now my door is what? Open, and I can go through it. But a multiplicity of 4, what happens?
It's shut and
It's shut, and I'm gonna bounce off. So anytime I have an even multiplicity, my graph does what? Bounces. Okay, so when we did parabolas, you could have one x-intercept, two x-intercepts, or none, right? The two x-intercepts, you had like x minus 2 and x minus 2, that was a multiplicity of what? 2, and so therefore it bounced off the x-axis. So you need to remember that because that will tell us more things. So we've got end behavior, we've got zeros, and we've got multiplicity. That's going to give us a really good shape of our graph without finding anything else. So f of x equals x times x plus 4 times x minus 1 to the 4th. Okay, so it says describe the describe the behavior of the graph of the function. So probably should find the zeros first, yes?
Yeah.
Okay, so we're going to set all of these things equal to 0. And I'm going to get 0. Oh, actually, we should probably start with negative 4, right? Because this would be negative 4, this would be 1, and this would be 0. So negative 4, 0, 1. And this is why, in this example, this is exactly why I do least to greatest. Okay? So my multiplicity is 1, my multiplicity is 1, my multiplicity is 4. So what I do is I just put a times 4 up there to tell myself it's multiplicity of 4. If you want to write multi of 4 next to it, go for it. Okay? I only care if the multiplicity is over 1. Most of the time it's what? 1? Okay. So when I multiply this out, when I FOIL all this out, this would be to the 4th, right? Then times another one would be to the 5th. And then times another one would be to the 6th. So we have a 6th degree polynomial, correct? So is that even or odd? Even, and all these x's are positive. So would it be positive when I multiply them all out?
Yeah.
Okay, so we have a positive even. So what's the end behavior going to look like? Up, up. Do you see how like this is math knowledge that I'm doing? I didn't have to multiply that out to prove it because we know what's going to happen, don't we? Okay, so our graph, we're going to go through negative 4, right? We're going to go through 0. And what's going to happen at 1? Are we going to go through? Nope, we're going to what? Bounce. And it's going to start up and it's going to end up. We can only cross at x-intercepts, nowhere else. So it's going to go here, come up through the 0, we don't know how far it's going to go up, but it's going to go up and then come down and then do what?
Go back up.
Bounce off. We don't even know what the equation is to that, but can we have an idea of what the graph would look like?
Yes.
Yes. See if I can put it in the calculator and you guys can see it. Okay, so this is the graph. It drops down. This is the graph. This is our graph. Did we know how far it dropped down? No, but do we have the right things? Do we go through 4? Do we go through 1? Did we bounce off 1? Or go through 0, bounce off 1?
Yes.
Yes. Okay, so our graph looks okay. Let me see. See if we can get a picture of it all. Nope, that did not work at all.
Stupid calculator.
Oh, so it drops a lot. See that? Like it drops clear down there. Because I don't even know what that window is. -40 and I still don't see it, do I? So what do you want to try? Like, let's go to like 10 on the max. What do you guys want to try? -60? Do I still see it? I still don't see it, do I? Okay, so our goal is to not graph a graph. Our goal is to sketch a graph. What's the difference between the two?
One's like
One's
exactly
exact,
how it is,
and
and one's just what it's supposed
Right.
to look like.
One is exact and one is what it's supposed to. Do we have the same general shape?
Yeah.
Yeah. Okay, so important things are zeros, where they bounce. When you get into calculus, we'll figure out the max and mins. They're kind of fun to do. But that's basically what we're doing. Okay, so let's do another one. So f of x equals x squared plus 9 times x minus 1 to the 5th times x plus 2 squared. So the first thing I do is set everything equal to 0. Okay. So here I would have x squared equals -9. And I take the
Square root.
Square
of
root.
So x equals 3.
so no, plus or minus 3 what?
Square. No, I.
Why is it 3i?
It's negative.
Because it's a negative. It's an even root of a negative. Any even root of a negative is going to have a what? I. Okay? So then this is going to be 1
Yeah.
with a multiplicity of
5,
5. And this is going to be
2.
-2
How's it 5?
because the degree is 5.
Oh, why didn't I see right that?
Okay? This is -2 because you have to subtract it over, yes?
Yep.
With a multiplicity of 2. Okay, do we graph positive and negative I? 3i. No. So these are zeros. Are all of them real? No. Imaginary numbers are not real, right? The x-intercepts are the real ones. And that's x equals -2 and
1.
1. So are there a difference between zeros and x-intercepts in what they are? Yes. Is there a difference, in how we find them? No. Okay. What degree is this? Well, this would be x squared if I multiplied it out, right? And this would be x to the 5th. And this is already x squared. So x squared times x to the 5th times x to the 4th would be x to the 9th. So we're working with x to the 9th. So is it odd or even?
Odd.
Odd. Positive or negative? Positive. Because they're all positive, correct?
Yeah.
For them to be negative, you'd have to have a negative coefficient on one of them, wouldn't you?
Yeah.
Okay, so it's a positive odd. So what's the graph gonna
Down, up.
down up? And it's gonna cross at 1, but do what at -2?
Bounce.
Bounce.
I thought it only bounced if it was even.
It is even, but -2 is a multiplicity of 2. So I'm gonna bounce and I'm gonna go through. Okay, and started down. Gonna come up, and it has to bounce if it's gonna end the way it should, right?
Yeah.
Now, I am going to tell you this plus or minus 3i usually adds a little wobbly somewhere. Like it might do this. See that?
Can you scoot your paper out, please?
Sure. Sorry. Might do something weird. There. That would be really weird if it was like that.
What should be exactly like that?
Yeah, that would be crazy if that was exactly like that. Plus 9. And you guys have a calculator. Could you put this in your calculator and check your work?
Yeah.
Yep. And to get my exponent, I'm just hitting the caret button.
We can't
Oops.
see. There's a
Okay,
glare.
just a second, just a second.
We're blind.
Okay, I'll put it in and then I'll adjust it. Bless you.
God bless.
Thank you.
Oh.
Okay, so I just put it in exactly how the problem was. See that?
Yep.
And then if you hit zoom 6, it gives you a square screen, 10 by 10. That's weird. 9x squared. X to the 5th plus 2. Okay, so there's something more going on there than we can see, isn't it?
Uh-huh.
Okay, so, oh, well, first of all, because I bounced off the wrong one, which am I supposed to bounce off of?
Dude.
2. Which one did I bounce off of? 1. So we would have done this, come down, I'm assuming. Would you have gone like that? Because it says negative, positive.
Mhm.
Okay, now look what it actually did. And this is because of that negative 3i. It actually comes from here and goes down and then back up. But there's no x-intercept because is negative 3i a real number? No. But this would be what I would expect you to tell me it looks like. Okay? So putting it in here, look for your x-intercepts. Look for that stuff. Are you doing that stuff right? Okay? Questions before we move on?
No.
Okay, so my directions to say what are the all real and complex zeros of the polynomial function shown. Okay, so they have a graph that looks like this. And it gives me the equation f of x equals x cubed plus x squared minus 3x minus 6. Okay? So it says, what are all the real and complex? So all the zeros of this. Well, I know one of them is what?
2.
2. I know that x equals 2, don't I? Well, can't I move it back this direction and have x minus 2?
Yeah.
Yes? So that would be a factor of it, wouldn't it? Okay? So if I synthetically divided by 2, I would get 0 as a factor, wouldn't I?
Yeah.
Yeah? And if I synthetically divided by 2, going down 1 would give me a quadratic, which I should know how to factor or use the quadratic formula, correct? So I'm going to synthetically divide by
Too many big words.
2. Okay, if it is a factor, when I synthetically divide, what is my remainder going to be?
2.
If something is
Zero.
0.
I tried.
Because 16 divided by 4 is what? 4. Is there any remainder? No. 16 divided by 5. Is there a remainder? Yes. Is 4 a factor of 16? Yes. Is 5 a factor of 16? No. So I know 2 is a factor, x minus 2 is a factor because it crosses where? At 2. So we're going to synthetically divide by 2. So do I have any holes? Everything in order?
3, 2, 1, 0. Yeah. that's
Okay,
not
so 1, 1, negative 3, negative 6.
Yep.
So 1, 2, 3,
Zero.
6, 3, 6, 0. Did my remainder come out 0?
Yep.
Yep. So now I have x squared plus 3x plus 3. I can factor or use the quadratic formula. Do the factors of 3 add to 3?
Yeah. It's x minus x plus c.
Do the factors of 3 add to 3?
X 3 add to 3.
3 and 1 don't add to 3. So we can't factor, we have to use the quadratic formula. What is it? If you don't remember, you better write it down. You better write it down anyway. What is it? Anybody?
Um,
I didn't know on the test, I wouldn't know that.
is that the
Negative b.
Over 2.
Well, it is all over 2a.
Plus or minus
negative
Plus
b
or minus.
plus or minus
square root of.
2?
I thought it was 4.
2 minus
Something.
AC.
b
And
squared
the ends with AC.
minus 4
AC.
ac. You guys have to know that.
I know. Oh.
Have to.
In 2 weeks.
No, you have, like, forever. Calculus just used it the other day, and I don't tell them anymore. If they can't factor, they use the quadratic formula. Like, it's it. You got to. Sorry. Okay. So A is 1, B is 3, and C is 3. So x equals negative 3 plus or minus the square root of 9 minus 4 times 1 times 3 all over 2. So negative 12
Negative 12, negative 2.
and 9 would be negative 3. So I have negative 3 plus or minus the square root of 3 I over 2. And
X equals
2.
damn.
Oh, and I probably should write this right. So x equals negative 3 halves plus or minus the square root of 3 over 2i and
2.
2. What is the only real 0?
2.
2. This is real. Are they all zeros? Yes, but is this the only real? What is this caused by right here?
A bounce.
that. Anything that puts a little squiggly into a graph that doesn't cross an x-intercept is caused by an imaginary solution.
I'm just getting a little scared.
I like get it. I just don't like when you use synthetic, like big words, because then you lose me.
Okay, let's do another one. So the function is f of x equals 2x cubed minus 8x squared plus 9x minus 9. The graph looks like this. So what do we know is a 0? What do we know is a 0? 3. Right? Okay, so we're going to synthetically divide by x equals 3, by the 3. So you do it, I do it. We better get the same thing. And we better get a remainder of 0, yes?
Yeah.
Because it crossed the x-axis at 3, it's a 0, so that means the remainder will be 0.
2x squared minus 2x plus. What?
Not done yet.
Mom, I thought you're slow. Doesn't make things as funny.
Okay, so looking at the graph, do I know that this is going to be an imaginary solution here?
Yes.
Yeah.
Yes, I know there's going to be an imaginary solution. I can check whether it can factor, but they're probably not, right? So the factors is 6 that add to 2. No, you can't get factors of a number that add to a number less than it, can you?
I mean, you could do some weird stuff, maybe.
No.
I don't know.
Okay, so x equals negative b, so 2 plus or minus b squared minus 4 times a times c all over 2a. So 624. So 4 minus 24 is
20.
negative 20. So 2 plus or minus this, and this is square root of negative 20. So perfect square root of negative 20 is 4, right? So bring out a 2, square root of 5, I over 4. I can reduce out a 2. So x equals 1/2 plus or minus the square root of 5 over 2. I and 3. So the only real one is 3. So if I were to graph, the only one that I would really acknowledge would be the 3. I could put a little dip to give me this. Okay, f of x equals x to the 4th minus 3x squared minus 4. And the graph looks like okay. So we know about this one. X equals what?
negative 2 and positive
Okay, plus or minus 2, right?
2. Yeah.
Okay, so let's do something called repeated synthetic division, just because we can. So do you want to divide by negative 2 or 2 first?
2.
2?
Sure. Yes.
Okay, we got some holes, right?
Mm-hmm.
So 1, 0,
Negative 3,
3.
0, negative 4.
So 1, 2, 2, 4, 1, 2, 2, 4, 0. Yes? We better got 0 because it's a 0 of the function. Better get 0, right?
X.
So now, wait.
No, I have to divide by the negative 2.
Now we're going to do negative 2. Because right here we're... Hey. Here we have x to the 4th. Here we have x cubed. Our goal is to get down to x squared, right? Or we can do the quadratic formula or factor.
Yeah.
So that's our goal. So if I divide a number, let's say if I have 64 and I divide it by 2, I get 32. Can I divide it by 2 again?
Yeah.
Yes, that's exactly what I'm doing.
And then again.
And again. Okay, so 1, 2, 4.
No.
How about
0.
negative 2?
Yeah.
Okay, 0, 1, negative 2, and I get a
0.
0. So now I'm down to x squared.
Yeah.
So I have x squared plus 1.
Mm-hmm.
Yeah.
Okay. So I'd set this equal to 0. Don't even have to factor it, do I? Subtract 1. So x squared equals negative 1.
And then you square root.
And what's the square root of negative 1?
Plus or minus 1i.
Or just plus or minus I?
Yeah.
So I have x equals positive and negative 2 and plus or minus I. So my real are
2.
2. And what did this I cause in this graph?
Uh-huh.
That hump. Now, guys, can I get the factors of 4 to subtract to 3?
Huh? 4 and 1.
The factors of 4 to subtract to 3?
4 and 1.
4 and 1. And so I would have x squared minus 4 and x squared plus 1. Yes? Because this is 4, 2. Can I factor this way? 6, 3. Can I factor this way? Yes. Okay. Well, this would be x squared equals 4. Take the
2.
square root. So x equals plus or minus.
That's what I was
2.
thinking as soon as you wrote that problem down.
And x squared equals negative 1 here.
Same thing in the
So
bottom.
plus or minus I. Now, does this always work? No, but if I can do it, should I pay attention and do it? Yes. I wanted to show you the repeated synthetic division. That's why we did this. But I could have factored it also and got the same. But you have to remember when you take a square root, what do you have? Plus and minus. Okay? This right here is called a conjugate pair. J, right?
Yes.
Okay, conjugate pair, and it always happens. Always. Every single time. Because how did I get the I? Taking the square root, the even root of a negative number, yes? So if positive there, what's also going to be there? Negative. So if they wrote x equals negative 2i and didn't tell you anything else, what also do you know?
Positive 2.
Positive 2i. Because it has to happen. They never come. They have to come in the positive negative pairs. Got me? Does it have to be positive negative 2? No. There's one more thing that always has to be positive negative. A conjugate pair. What if I had the square root of 5? Doesn't that have to be plus and minus?
Yeah.
because you got it by taking the square root. So that will really come into play tomorrow, but I wanted to, I think, maybe. Okay, I don't want to go too far. I want to get what you need and stop. So let me check something here real quick, okay? You're starting at 19.
Yeah.
I feel like I've skipped. I feel like you should have started at 12.
No.
I mean, that's fine.
No.
No.
I like what we have. I think I like what we have.
Yeah, but that's not what you're doing. Okay, one more example. I'm gonna restate the assignment. I'm kind of confused what it is. Okay, so it says, what are the solutions?
I don't know. What are they?
Oh, sass.
Okay, 2x cubed plus 5x squared minus 3x equals 3x cubed plus 8x squared plus 17. And it says, what are the solutions? So what's the first thing I need to do?
Combine like.
Can't combine like terms. You have to set it equal to 0.
That's the one that I meant.
Okay, so are we going to go left or right? I'm going to go right. Why do I want to go right?
Because it's bigger.
Because does it keep my leading coefficient positive? Yes. Does it really matter? No, but if I have to factor it, I'd factor out a negative, and I don't want to have to do that, right?
No.
Okay, so minus 2x cubed minus 5x squared plus 3x. Right?
Yeah.
So then I get x cubed plus 3x squared plus 3x plus 17. Oh, that's not 17, that's a 1. They have a question mark. I'm like, what they were doing, I'm like, no, that does not work. Okay. So, well, we got another method we can factor by grouping, right? Yes?
Sure.
Can't we? We've done that before. We have 4 terms. That's what grouping is, right? Okay. What do they have in common? X squared. What about these? What do they have in common?
And then nothing.
1, a positive 1, right? Always that sign.
Yeah.
And what are you left with? Oh, that didn't work. That didn't work. Why didn't that work?
And then 3x.
Because are they the same?
No.
No. So grouping didn't work. Okay. Well, what do you guys notice? 1, 3, 3, 1.
What?
1, 3, 3, 1. That doesn't remind you of anything?
No.
So,
Oh, that thing.
Oh, yeah, it does.
I wasn't really here that day.
Okay, this is row what? 3. Right? And my coefficients are 1, 3, 3, and 1. They haven't changed, right? So wouldn't that make this x plus 1
X.
cubed?
Yeah.
So x equals negative 1 with the multiplicity of 3. Okay, I will adjust the assignment. You're going to start on 12. I don't quite know why I have 19.
Well, looks like I'm not doing it.
Probably 9.
I know it's going to be like 12 to 16,
I only told 6.
and then 19 through 21.
Okay.
That's what your assignment's gonna be.
That's not bad.
I will get it fixed. I'm sorry, guys. I don't. It like started in the middle. Like it started with these.
We're all people,
We're all
we're human.
human, okay?